Hello everyone, my name is Michael Wall. I am a consultant and database administrator for 3Cloud. I've been in the IT industry for well over 20 years now. I started off as, well, first actually working with customers and helping them with their DOS problems, and eventually became a Unix administrator. Did that for a couple of years, and then I was asked if I wanted to be a DBA, and I said, sure, why not? So, which started off a very interesting and diverse career, working my way through many, many learning experiences. Originally, I learned all about Oracle on Unix and then started working with SQL Server. I spent a long time supporting Ingress databases on VAXs, and now currently I'm pretty firmly in the Microsoft stack. I made that decision a couple of years ago, number of years ago, and haven't been sorry about that. Microsoft is a great company and they have great products. But anyway, we'll talk about me a little bit more as well. But first of all, welcome to the first Virtual Summit of PASS, Virtual Summit 2020. I'm so happy that you're here. We're going to be talking about Polybase, which is a very interesting technology that Microsoft released about 3 years ago, back with SQL Server 2016. And it's gone through a lot of changes, mostly for the better. It still has some definite room for improvement, but the main thing is what it does is it allows you to virtualize your data, and which is really exciting when you think about that. But first of all, let's talk about PASS a little bit. So I've been a member of PASS, the Professional Association of SQL Server, for a number of years, I think 10 plus years. I recently, as you can see here on my screen, I just recently joined as a PASS Pro member, and I have to say I highly recommend this. So right out of the gate, I think it's $80 I paid because I managed to get my membership in before October 15th. I just got an offer from PASS in order to participate in a 4-week learning workshop, which is going to be taught by people like Armando Lacerdo and Bob Ward. And it's going to be about the brand new Azure DBA test, which is entirely appropriate for my career. So I'm really excited about that. And I've been through a couple of these before. I went through and did that when I did the, the Azure 900 test, the Azure Fundamentals test. I went and took that. And I also, for the data engineering tests. And in all those, I went through and I took the workshops that were provided by Microsoft, which led through the guidelines for the test. And then the best bonus is that you get a discount, either 50% or 100% for the actual exam voucher. So right there, I got paid back. PASS has been really important to me. I made that decision about 6 years ago, but really 5 years ago, I just really dove headfirst in there. And I've not been sorry at all. I've met so many nice people, so many wonderful people all over the world, but locally, I really enjoy working with the local groups. I enjoy supporting them. I enjoy presenting, and just can't talk enough about it. All of us obviously are in a weird world right now where we can't physically travel and go meet people, but the virtual world has really expanded our horizons about where we can meet, where we can speak. I had the opportunity to speak at the Southwest England group not too long ago. That was a lot of fun. We just had our SQL Saturday Oregon just barely 2 weeks ago. And we had presenters from all over the world. What a great opportunity. So once again, go join PASS. Obviously, if you're here, you must already be members of PASS, but tell more people about PASS. PASS is a great thing for everyone, and you just need to belong. So as I said before, I've been a DBA for a long time. I've supported databases on a number of platforms. I've really, in my mindset, Azure is really more of a OS platform than anything else. I understand that it's so much more, but when I think about it as far as an architecture point of view, it's no different from learning all the tricks and tips for Azure as it is from learning Windows or VMS or for Unix. All these different ones. As I also said right here, I'm a huge supporter of community. Things have been curtailed a little bit due to the virus, but reach out. There's lots of speakers who would like to have a chance. As I go into my next picture right here, why aren't you up here? I can guarantee you that if you reach out to your local group leader and say, hey, I've got something I'd like to talk about for 15 minutes, they would be more than happy to fit you into the schedule. They'll work with you on how to improve your presentation. And you're going to have this, you're going to just start off in this wonderful world where you're going to meet all these neat people, and you're going to be really forced to learn more about your topics. And that's what I think I have really enjoyed the most about doing this, is that I will purposely pick topics that are a little bit out there. And maybe in the beginning I picked ones that are a little bit too out there, but now I've picked these topics that are challenging, yet they're also effective in order to help me on my career. And it's also fun to talk to people about these different topics and learn a lot of different things. I mean, for instance, right here, we're going to be talking about Polybase. And here we have the only Polybase book out there, Polybase Revealed by Kevin Fiesel. And it was a great opportunity. I got to talk to Kevin. We had a few chats about some of the different topics. Again, what's wrong with that? But as we go back, and also I do have my blog, which sadly I've done exactly what I'm afraid happens with a lot of blogs, is that I was gung-ho in the beginning of the summer, and then I got busy with work, and I haven't done anything. But I would still encourage you to go take a look at my blog. Becoming a master, it's one of the things that I'm really passionate about, is professional development, about passing on your knowledge, and that's one of the reasons I enjoy being a speaker. So there's your opportunity to read that, and I am going to be blogging about Polybase and big data clusters because that's my current interest right now. But anyway, let's keep on talking about Polybase, or let's start talking about it. So in the beginning, the Polybase story has actually been around since 2011, when it was originally come up as a concept by one of the Microsoft fellows. It's become much more important now because Microsoft has put all of their time and effort by pushing forward the big data clusters concept. And Polybase is one of the main pieces of glue that sticks it all together. Because if you're dealing with big data, how are you going to get big data to you? As I mentioned before, Polybase originally came out in 2016. Bob Ward named it in his book, SQL Server 2019 Revealed. I'm looking over at my bookshelf right now. Yes, 2019 Revealed. I couldn't remember. It's just SQL Server Revealed. But anyway, it's an excellent book. It's a great overview for read over the topics. And the nice thing about what Bob does is that he goes into detail and he gives you some real demos too. It's not just talking about it, but he shows you what he's doing, why he knows it, and how he learned it. And he talks quite a bit about the origin of Polybase in that book. But he refers to it as we have version 2, or version 1, which is the one that came out with SQL Server 2016-17. And then we have version 2, which is the one that's with the current SQL Server 2019, which is where it gets really interesting. And just to make it even more confusing, there's actually a different version of Polybase for Azure Synapse, which has its own quirks and limitations, just like all the rest of them. As you look here, this is one of the original drawings about Polybase. So this is back when we had SQL Server Parallel Data Warehouse was the first concept. I mean, you can see here at the bottom of the slide, you can see SQL Server 2012. And this is when big data was starting to become a concept. I mean, look over here. We have all these different ideas here about how is IoT going to be coming in through sensors and through devices and through bots and through crawlers. They were just ideas at that point. Here's Hadoop right here, definitely a big thing. The Azure Marketplace. Back in 2012, Azure Marketplace was a lot rougher than it is now and not nearly as polished. Of course, you have your ETLs. And then you have all your traditional ways of bringing data in for reporting data. You have your analysis server for making your data warehouses. You have your reporting server for reporting data. And then you have your data marts, which one of those concepts which I'm not quite as familiar with. And then finally, you have your dashboards. Dashboards were also becoming very popular. That's 2010 is when dashboards started to become a concept. So Polybase was just mentioned right here. And even though ETL was still on here, I don't think it was quite realized. And because of this, we had some visions about what Polybase was going to be. The main thing is that Hadoop was realized that it was definitely a reality on the big data landscape. Scalability. It was recognized that if you have something that is big, as far as the big data that's in Hadoop, you needed to have something that could work with Hadoop, but not necessarily bring the data over. I mean, even back then it was realized, hey, we're going to have a lot of data, and while yes, obviously we can use ETLs and we could use SSIS or Azure Data Factory now, the main thing is that that's a lot of data to bring into the database. Flexibility, because back then there were a lot more versions of Hadoop. And then finally, integration works with the Microsoft BI tools. So again, all of these were back in the early 2010s, and the Microsoft story was still evolving at that point, and so some of the terms used back then aren't the terms that you use now. David DeWitt is the Microsoft technical fellow who actually wrote the original paper, which is actually really interesting. And I will read it out loud for you, even though you can read it on the slide yourself. Polybase only works within Parallel Data Warehouse for now, but later might be added to SQL Server, but there are no plans for it. It relies on the data movement service in Parallel Data Warehouse, and data movement service does not exist in SQL Server. This is all very true. And we are going to spend time in my final demo looking at the data movement server, but it did not exist back then. And until it existed, it just didn't work. It didn't make any sense. And again, his last statement, it may in the future be able to access other storage systems besides Hadoop. But in order for it to become, the technology was there, but the drivers had to be there first too. And really what it required was the complete development of Azure. Azure was there, but I mean, where it became a reality. And what we're talking about is Synapse. So we went from Parallel Data Warehouse to Analytics Platform System to Azure SQL Data Warehouse in the cloud, and then finally Azure Synapse. So all of a sudden, there was a reality where this huge amount of data could be stored in the cloud for customers. But then the question is what did you want to do with that data? Where do you want to put that data? How did you want to deal with that data? And Polybase was supposed to be the answer. It came out and it worked. It had problems, but it did work. Now, again, we're talking about version 1 of Polybase as described by Bob Ward, which I think is the best way to look at it. So in SQL Server 2016, Polybase was a new feature, but it was limited only to Hadoop, to blob storage, and to the earlier versions of Data Lake. But it worked. That was the main thing, is that so it did reach out to these different storage systems, and it could grab data. One of the demos we're also going to be doing is we're going to show how Polybase talks to blob storage. So I think you'll understand how, while it may seem like a little bit complex, it's actually very simple, and it's just really neat how that you're able to access the data once again without having to worry about getting it all localized on your server. I mean, again, back to the original concept is it was supposed to use a common language, which was T-SQL. So all of a sudden, all of your data that's in Hadoop could be joined. And that's what the magic of Polybase really is that you could join your data in Hadoop or blob storage or data lake, and you could use a T-SQL command in order to join it. And all of a sudden, this data is just there. It's available. Now, granted, it's not, there is a little bit of latency. There's always going to be a little bit of latency whenever you're moving large amounts of data. But the point is that you don't have to physically join it and bring it into your database anymore. You can just go ahead and do queries on it. One of the other concepts that was added into it is using in Hadoop the whole MapReduce technology. So it was smart enough to tell Hadoop, hey, use MapReduce in order to lower the demand on the source system. Use your optimizer and make it work faster. But as I described, a fairly limited view of why people would want to use Polybase, which is why it didn't really take off in version 1. Hadoop which was, while important, it still was limited in the places where people could use it. And of course, data lake was still fairly primitive. And blob storage, well, blob storage is used mostly to store spreadsheets and older files, older data. And so it just wasn't there. I mean, people wanted to have real-time data. But enters big data clusters. So if you haven't heard about big data clusters, now's the time to go look at it, because it's pretty darn interesting stuff. And this is what Microsoft has been working on in order to bring themselves back, I think, into the big data story. I mean, obviously, Microsoft has been part of the big data story for a long time, but big data clusters is truly impressive in what they've managed to accomplish. They are realizing that the whole world is data. I mean, the whole world has always been a database, especially since the late 1990s. All this data was out there, and now companies are grabbing more and more and more. And can I say more again? It's not so much that the data itself is big, it's just that the quantity of data is out there. And so there has to be a good way in order to process all the data, and that's where big data clusters comes in. And I understand this is a presentation on Polybase, but I think it's important that the Polybase story would not be successful if it weren't for big data clusters, because big data clusters came about and Polybase was improved and made more resilient and made more accessible because of big data clusters. It was incredibly important for Microsoft to have that tool that would allow them to do that. Now, if you look here at I'm going to look down at my drawing and move my slides around. The main, there's 3 different sections here. But as you can see right here, Polybase gets 1/3 of this slide talking about big data clusters. Because reading the Microsoft marketing here, but combine data from many sources without moving or replicating it. Scale out compute and caching to boost performance. So that's what Polybase does. It can reach out and it can talk to many different data sources, but it also, you have the option to scale out and add more nodes to the cluster depending on how much data are you trying to move. And so I apologize for using the term cluster, but I mean, that is the term. The word cluster is tossed around quite a bit. I mean, obviously we have a Windows failover cluster, we have big data clusters, and then we have the scale-out cluster for Polybase. And so it's composed of nodes. And in the demo that we're going to be talking about, I have 3 SQL Server 2019 VMs in Azure, and each one of them is part of a scale-out cluster. Each one is a node. But in the rest of this, I'm not going to go into so much. I mean, it's important, you should read up about this, but the whole idea is that it's all about ingesting the data so it can be processed and utilized by the business, utilized by the users. So here you've got your storage right here using SQL Server and Spark and Data Lake, and then also here you've got your AI platform, which is where you're taking the data, you're analyzing it, you're manipulating it, you're digesting the data, you're getting it ready for reporting, but it's all about data. And because of that, in order to make big data clusters successful, it was important for Polybase to be able to talk to a lot more than just Hadoop and blob storage and Data Lake. Because of that, all these connectors were made. So now Polybase will talk to Oracle and Teradata and MongoDB and of course Cosmos DB, because we can't forget that one, and SQL Server, which was probably the most important piece right there. And if that didn't work, you always had ODBC connectors to cover all the missing gaps. I think that's why this is so exciting for me as a DBA. I've been a DBA for a long time, and I have to admit that I had a bit of a personal career crisis, and I thought that I wanted to become an Azure architect. But what I realized, that's what I said, how that I think of Azure now as an OS. I went through this little period of time, but realizing that, again, it gets down to about being data, and database administrators are the ones who are going to help move that data around. we're the ones who were trained from the very beginning on how to optimize the movement of data, the storage of data, the retention of data, making that data available. That's what DBAs have always traditionally done. And that story has changed a little bit due to the huge rise of the business intelligence arms. But now's the time for the DBAs to take back your power. So data virtualization, that's a term that we're going to be using quite a bit. Again, another term that was coined by Microsoft. Again, I took it once again from that wonderful book by Bob Ward. But it's exactly what it is. I mean, it's virtualizing the data. So you're not visualizing the data. Visualizing data, I know lots of great people who know how to visualize data and turn it into reports and dashboards and presentations. This is about virtualizing data. So imagine, if you would, you've got a whole mess of data right here in this container, and here is your reporting platform. So instead of actually taking this data and scooping it all up and moving it onto your reporting platform to make it available, instead the reporting platform just reaches out and it virtualizes that data and it reports on it. So all of a sudden you just took away well, not all of them, but you took away a tremendous amount of IOs that are required in order to get that data, because it's not just one chunk, it's also that real-time data flow. So let's imagine that you have to report off of 1 terabyte database. So there's a lot of different ways you could do that. I mean, whether you use replication, or if you used AlwaysOn Availability Groups or something, or do an ETL. And there's also the time too. So imagine how much time it takes in order to isolate the actual data that needs to be grabbed. So instead, your reporting people already know what the data is that they want. So they take it, they virtualize it, they see the tables in the source database, and then they just do a join. I mean, it's kind of neat here. This is what it does. As you can see right here, Microsoft Marketing, showing all the different places where that you can put it into a Polybase external table. So external tables are not new, and external tables are actually an Azure SQL database as well. Now that's not actually Polybase, it's kind of a derivative of it. That's Elastic Query, but it's very much the same thing. But the main point is that you will use external tables to go ahead and make the data virtual and available for your use in the business. And so from the book that I've quoted before, as part of the overall strategy for SQL Server 2019 to implement a solution for data virtualization, our hope and promise is that SQL Server is an excellent center for data virtualization. In other words, SQL Server can become the data hub for your organization. I think it's really important to remember that term. Again, the basics of Polybase. The data stays on the source machine. No more ETLs, no more copying over. Data just sits there. It keeps on growing. And if you want to do real-time reporting, well, that's fine. You just run the same report 5 minutes later, and guess what? All those transactions that were done by whatever the source system are available. And you didn't have to worry about a batch job that's going to move the data over. You just reach out and touch the data. Distributed computing is used where possible. So that, again, that's where the idea of the scale-out cluster, where you have the different nodes in case you need more performance. It also applies to on a Hadoop data source as well, but we're specifically going to be talking about the SQL Server parts of it. And then finally, T-SQL, a well-known language, is the language of choice. So there is no time loss because your developers already know how to do queries in T-SQL. So they're just going to reach out and grab these tables. Here's another really good slide, but it shows what the vision is here. And look what's in the middle, SQL Server 2019. Again, the data hub. As I said, take back your power, DBAs. This is really important stuff. So you as DBAs are setting up the database. You are creating the external tables, which are connecting to all of these different data sources right here. And then people do queries right here. You're making it available. Kind of neat, isn't it? This slide, and I would be more than happy to email people directly if they're curious about this. This one is about the only slide that I've been able to find that shows the difference in the versions of what we are calling Polybase version 1 which is on the SQL Server 2016-17 release, SQL Server 2019, which is the version 2, and then finally the different version that's only on Azure SQL Data Warehouse, now called Azure Synapse. Does it work on Linux? It does, kind of, because SQL Server 2019 works on Linux, but one of the problems there is it doesn't support the scale-out nodes. So you lose that distributed computing ability. So I can't really support using it on Linux. I mean, if you have to, you have to. But you know, you're missing out on part of the excitement about using Polybase and being able to just scale up and down as needed. But let's talk about the Polybase install. We're not going to go through a full install. I just want to show some of the few key slides here. So again, you go into your SQL Server 2019 install. Again, I'm going to recommend always that you do SQL Server 2019, and also I would recommend that you stay up on the current patching. There has been a lot of patching on Polybase, and I think it's important. So I refreshed my test machines to put on CU8, but I remember back when I was working with CU4 and I put CU5 on, and all of a sudden things that weren't working worked better. So it's really important to remember this. But as you're doing your install, you've got here, you need to install the Polybase query server, and the Java connector is only if you're talking to Hadoop data sources, but I went ahead and put it on. This is the key part right here. So you might as well go ahead and use, click on the part of the scale out group when you're installing it. It doesn't mean that you have to do it, but it's just an option. Otherwise, if you set it aside as a standalone Polybase enabled instance, and that means that you have to go back and you'll have to reinstall, go through the setup on SQL Server in order to get that done. Again, Java install, this is if you want to talk to Hadoop. Unless there's a real reason not to do it, you might as well put it in just so that that feature is available. You have to have individual accounts. So one of the other requirements about Polybase is that you need to have AD set up. So I went ahead and set this up. I have an own account, a separate account just for the Polybase engine and the data movement service. And finally, let's get to some of the concepts. So here we are, external data source. This is in Hadoop. Hadoop's a little bit special because you have to go ahead and put an external file format into there. That's kind of one of those legacy pieces, but all it really means is that you're just looking at what the type of data that you're digesting. Same sort of concept you would be using with something that you would see in blob storage as well, or data lake probably for like CSV files. So here's the syntax right here. I am creating an external data source with this name, telling what the type is and then the location. And so this is in blob storage. This happens to, I'm sorry, right. Even though it's from Hadoop, it's actually in blob storage. And so it's reaching out and it's grabbing this URL. And then this is where I'm identifying the file format. So that's important, again, in dealing with CSV files and such like that, to show the terminators and the string delimiters. And then I'm going to create an external table, which is just grabbing the columns from the table. And here's the source right here, the location, which in this case is going to be the tab on the spreadsheet. And then finally, right here, we have our data source. So using the file format, and then the reject value, I set it high, which is, that's important because is when you're ingesting data, and you're not really ingesting data, but you still are ingesting it, you're virtualizing the data. But the point is that I found it useful to set a high reject value just so that you can get the data and you can review it, and then maybe you can go through and clean it up later. And when I'm done, I have these external tables right here in my SQL Server. So let's go back a little bit again. So I went ahead and I created an external data source pointing to blob storage. I went ahead and created an external table right here based on the fields that are in the table from the spreadsheet. And I use the same data source, so it makes it simple there. And then finally, at the end with SQL Server, all of a sudden I have external tables, which is a feature that you'll see. So as you go through here, and if you can take a look here and you can see the external tables yourself. So it's a little bit different in SQL Server. In SQL Server, you have to go ahead and create a master key with encryption. So you have to set up your password, and then you have to have a database scope credential. One of the gotchas here is that you can create all this stuff, and it will go ahead and put it through, and even if you don't get it right, and you won't find out until you actually try to test it. So make sure you write everything down. OneNote is your buddy. Keep track of everything right there. So in this case, going through and creating the external data source. So again, this is, instead of a Hadoop one, this is actually on SQL Server. So I'm saying right here, so this is the location, as you can see right here, so letting SQL Server know that this is a SQL Server data source, and then finally I'm adding in the name of the SQL Server right here, and using the credentials. From here, I create the external tables, same concept. So I know what the table structure is on the source server, and then I'm creating the external table locally. So again, this is just a pointer to the table. I'm not actually moving data. It's going to virtualize that data so it's visible on my destination server. And as you can see right here, once again, here we have external tables that were created. And so I went through and created the external tables. Now, the naming was my choice, but they have to be named something different, especially if you're going to make internal tables. And that's one of the things that you may decide that you want to do, is that once you have the tables externalized onto your SQL Server, then you may want to go ahead and create internal tables as well. It's kind of depends on how you want to work with it. I mean, obviously you're going to take out any performance hit if you do it, but I mean, and I guess it's really just another way of doing an ETL. But the point is that you could do that, but you do have to create the names of the tables with something different. So again, just to reiterate the point, they are external tables, and they're just pointing at the original data source. I mean, they're pointers, metadata, they're just talking to it. A term that I've used for a long time is the pivot point, the pass-through, to utilize the data. So all of a sudden, you could just go ahead and make sure that all of these external tables are available for you and for your customers, and they can virtualize this data. Whenever it can, Polybase is going to offload the work. It's going to use the pushdown predicate to the external data source. So that's going to help, the SQL Server Optimizer understands what it's doing, what that means, and it's going to do that when it can. But let's go ahead and look at some of the demos and just go through some of the process here. All right, everyone. So here we are in my demo system. I've gone out and zoomed in just to show you. So this is a recently refreshed. So here we have the database right here. And as you can see, there are no external tables created. There are no tables created. So I'm going to leave zoom in just so I can do the control. And what I'm going to do is this already will fail because I've already dropped it. And then here, we're going to zoom in and take a look at the external tables. So I am creating external tables right here based on this data source. This, you can see right here we have this NYT public data source, which I've already created. So I'm going to exit out, zoom it, and I'm going to show you, we're not going to recreate the data source, but I'm going to show it to you again. And then if I go back into zoom it, you can see right here, much like we saw earlier in the presentation, you can see here, create the external data source. So again, I'm reaching out to blob storage, creating this. It says type Hadoop, but that's just because of the format. Put that back. So now we go back to the statement here where we're going to create all the external tables. And let me just show you a little bit more once again. So this one here is a little bit bigger table. And as you can see here, the slightly bigger. Once again, you have to match all the columns of the external tables in order to make it work. So I'm going to hit execute right here. It doesn't take very long to run, so it's done. Because all it's doing is not actually moving any data. It is just merely creating the pointers to the external data. So now, just for the purposes of demonstration, I'm going to show you here that I'm going to create some internal tables just for fun. Again, it's not going to take a huge amount of time. We're not talking about a lot of data here. I think it's only like about 1.5 million rows. But the point is that this data is all of a sudden virtualized. So if I wanted to make this, so let me go back into Zoom it and show you right here. So here we're just selecting from, we're creating the tables from the external tables. And you see right here, and let's see if we can get down here to the query time. No, Zoom is not showing that. But as you were watching, it didn't take very long in order to complete this. So that's the main thing. So that's the simplicity of it. We're not going to do another external data source just because I want to spend time on the demo showing you the scale out nodes. But once again, you saw how simple it was to just really create the external data source, and then I was just able to create the external tables and look at them. One of the things right here, so let me go ahead and refresh now that this has been created. And as we look here, you can see here are those external tables that we created. And if I were to go ahead and select, it takes a little while. It's still pulling the data across. But the main thing is that instead of having to connect to a different database, to a different server, or to copy the data locally, what you're doing right here is that you're able to just do, you have your external table, and I just did a select. It's as simple as that. And we'll do another one right here. See, let me zoom back in a little bit. But just a simple select top 1000, we have data. Simple as that. I mean, it really is. So we're going to go back to the main presentation. So very simple demos. I understand we were going to do some, we saw that we didn't actually do any joins, we did a straight select. But the point is that where you can move forward. So let's start talking about the architecture about Polybase a little bit here. This is where it's important to understand it. So one of my goals here when I first wrote this presentation was to show how Polybase worked in an HA environment. So these databases are actually, I wanted to see how it worked with AlwaysOn. So Polybase is not truly HA aware, but it has its own version of HA. And I wanted everyone to be aware of it because unfortunately it's still not perfect. There's a lot of moving parts here, and you have to do a lot of manual intervention, which is unfortunate. I think Polybase is wonderful. I would love to evangelize Polybase, but I think that there's still some features here that need to be fixed. And so I wanted you as DBAs to be aware of the use of Polybase, especially if you were to put this into your environment, because things happen. And if you, let's say that in my case, what we're going to do is I have a 3-node cluster, and we're going to kill one of the nodes and we can see what happens. And unfortunately, because these things happen, it's not seamless. I wish it could be. A lot of it actually can be scripted out with PowerShell, and I've done that before. I did that for a couple of different customers. But you have to be mindful of what's going on there. So as we look right here on the image, let me see if we can, yeah, here we go. Let's make that a little bit bigger for everyone, because this is important stuff. So the main thing is that you have, again, you have your head node. There's always going to be a head node. And then you have the compute node. And this can be scaled out as many times as you want to. And so this is where you get that extra, that distributed computing. That's where you get that extra power. So whether you're doing a standalone instance or if you're doing scale-out nodes, the point is you're still going to always have a head and a compute node. Just the difference is that if you do a standalone edition, your single server running Polybase will have your head and your compute node on itself. It has both of them because both are essential. The head node is for keeping track of everything and the compute node is for moving the data back and forth. But if you were to add in multiple nodes, then they would show up as additional compute nodes, and we're going to take a little look on how that's set up in this environment. So again, you can see here. So you have there are three Polybase databases, but again, you have the SQL engine, the Polybase engine, and the data movement service. And TempDB is really important. So Polybase knows all about TempDB, and it's going to use it when it's doing its processing. So as I said, that there'll be two services. Both you have your engine as well as the data movement service are going to be installed on each node in the scale-out cluster. It's just a matter of whether they're actually going to be utilized or not. So the engine service is only utilized for the node that's identified as the head in the cluster, while the data movement service is going to be installed and it'll be always on for all of them. As I said, I wanted to see how it worked in an HA environment. I mean, it runs just fine, but it's not truly HA available. I haven't quite figured out a way in order to make it so that it actually will show up as in HA. So let's go into our next demo. All right, everyone, here we go. We've got our demo going here for the main part of the show. So I'm going to use Zoom In so you can see what we've got set up. So once again, this is a 3-node Windows failover cluster with AlwaysOn enabled. And as you can see right here, we have MW test AG1, AG2, and AG3. And you can also see the Polybase scale-out groups. So, and I've been using scale-out clusters, so scale-out groups. And as you can see right here, so right now, AG1 is the head node. And it is designated right there by head and compute. AG2 also understands that AG1 is the head node, and it is going to be the compute node, so it's going to help out in the processing. Finally, AG3 also will do the exact same thing. It understands that AG1 is the head node and AG3 is a compute node. So one of the things that I wanted to point out is that there are some DMVs out there. Now, I have personally had some problems with the accuracy of these because when I run this DMV, and we scroll right back in here, it tells me a slightly different story. So based on this, I would have to say at this time that I would trust what you see in SSMS. Because until I can figure out why it is that this view says this. So right now the view seems to be confused about which node that it's running on, and it seems to think that it's the head node, which I think is an artifact from the fact that from the scale out, the concept of when it was installed. So I'm not quite sure. Something I need to work on. But what we're going to do here is that we're going to go ahead and we're going to fail over the head node to a different server. So let's say in case you knew you needed to remove a server from the cluster or something like that. So the way to do this is a little bit awkward. I recommend, even though you can actually do it through SMS, in this case I recommend using T-SQL. So as you see right here, we have this stored procedure Polybase join group, and this is where we tell it what we're going to do. So what I'm going to do here, and I'm going to have you sit through this because I think it's important, is that I'm going to tell Polybase right here on all 3 nodes, this is on O3, that I want to go to AG2, that AG2 is now going to be in charge. So now I'm telling AG2 itself that's in charge. And I'm going to tell AG1 that AG2 is now in charge. So what's an important thing here is that this message always pops up right here. Engine services disabled. Please restart Polybase DMS service. So it's important to remember this. And so this is where the cumbersome part of dealing with Polybase comes into. So you have to go into the server. I apologize. I'm going to swap things around. I'm going to expand things. Let's see. Let's see what we're doing here. We want to get my services window up here. And I think people can see that I opened up a services window. So right here, as we go into zoom it, you can see right here that we have the Polybase data movement service, and then we also have the Polybase engine service. So notice how right now that data movement is running, it's an automatic, and engine is running and it's a manual. Now we're going to refresh that because this is on AG1. Now when I go back in here, this is the quirky part. So even though the stored procedure actually moved the head node over to AG2, it's still running on AG1. So because of this, I have to do the following. I have to go ahead and I have to stop the engine service on AG1, and I need to restart the data movement service on AG1 so that it understands that there's a new boss in town. So as we zoom in again, you can see that's exactly what I've done. The disabled part comes from the Polybase service itself. It automatically, the stored procedure disables the service. So now we have to do this on all three nodes. So once again, we're going to go here and take a look. So this is what it was before, because it was running normally and the engine service was not running. I'm now going to refresh services. And boy, I mean, look at this. So we have the engine service is not running and data movement is turned off as well. So what I need to do again is that I need to, since this is AG2, I need to change the properties. And once again, this is all very PowerShellable, so I highly recommend going to PowerShell, doing it that way. I need to set it to automatic so the service will start. I need to start the engine service once again because we're making two. Two is now the head, so it has to have the engine running. The rest of the nodes don't. And then finally, I need to restart the data movement service so that it understands two. And now we are going to go over to 3, and we are going to, once again, so as we zoom in here, you can see that the engine service, this one wasn't actually running the head node, so it's not a big deal, it didn't have it, and the service, the data movement service is running. So all I have to do here is I'm going to refresh it just to make sure, and then I just need to restart the data movement service. So I know that seems like a lot of work. Scale out nodes are still obviously have some work to do. They work just fine once you get them set up. It's just that if you actually have to have some sort of a change in your environment, you have to be aware that there's a lot of administration involved here. Again, it can be fixed with PowerShell somewhat, but you still have to be aware of what's going on here. So I am going ahead, so now we're back on AG1, and what I'm going to do is I am going to refresh on SSMS because I want you to see. So I am refreshing the cluster. And don't worry, I'm going to zoom in. So now as I do that, you can see right here that now it does truly understand that AG2 is the head. This is AG1 sees it, AG2 understands it, and finally AG3 understands it. So again, it's an administration part. I am actually going to publish all my Polybase, my PowerShell scripts on my blog for how I automate this process. And so you're certainly welcome to it. And of course, you can email me, and I would be happy to send you the scripts that I use. In fact, I can show you just quick and dirty, just to give you some of the idea of what I'm doing here. But it's as simple as this. It's just a matter of taking the service, you go and you identify the name of the service, you go and you have to restart it. But the key part here is that you have to actually, you have to also set the service. In order to start a service, you have to make sure it's set either to manual or automatic, and then you have to set the status to running. So just a couple things that you need to be mindful here. So let's go ahead and we'll go through and do this quickly. I want to make sure that there's time for questions and everything too right here. So I'm going to, so here's my Azure environment right here. So I'm going to go ahead and yank the plug on AG2, which is the head node, because I want to show you what the errors are. I don't think we're going to go through the whole process of switching around, but I want you to see what happens. So this is AG2. Zoom again. AG2, Azure. All I'm going to do is I'm just going to press stop, which is going to kill it. Takes a little while. Just like when I'm in a crosswalk, and it's always helpful if you hit the button for the walk sign multiple times, because you know that makes it go faster. I hope all of you are having fun though at Past Summit. I hope it's enjoyable. It's certainly a great experience though. I think it's really important to get out there and talk to people. So it looks like it's pretty much deallocated, so we're going to go ahead and get back into it. So right here, so now I am going to run that query, even though I said that it only works so well. So we've got a couple things going on here. So what's going to happen is that Polybase is going to remember what happened, and it's going to say, it's going to go ahead and it's going to want to hold on to what was there. So if I were to run this query right here, the node, it's going to eventually time out, because first of all, it's going to say, I don't know who I am, where's the boss, I'm not quite sure what's going on. And unfortunately, it still remembers right here in SSMS, if I go through and I refresh, that one's unavailable. So SSMS still thinks it, because what happens is that the services need to be restarted manually. That's the problem, is that there's not a dynamic flexibility in there. Now, I understand what I did was not very nice to Polybase, but these things could happen. That the server could lose power, that something could happen, you make a change and you don't realize that you need to change Polybase in order to fix it. So then it goes and times out, so anyway, here we go. Here's this error I was looking for. So this is the error that you're going to get from Polybase if it is unable to connect to one of the members of the nodes that it thinks, one of the nodes that it thinks it should be able to connect to. So because of that, if we were to do this, let's see how quickly we can do this. I'm going to go ahead and quickly I'm going to start the service. And this time I'm just busting through them so we can get this done. And we're going to find our services right here. And I'm going to refresh it. And so what I need to do is that I also need to go ahead and enable the service once again. Apply, OK, start. So we're starting up the engine on 1 because 2 is down, and we're not going to bring back 2. It's gone. So once again, I had to re-enable the disabled engine service because 1 is now going to be in charge again. It's going to be the head. I am now currently, and you can see this, I am now currently starting the service, the engine service right here. Still waiting for the service. It's still coming up. You can see the little green bar. I'm not quite sure why it's taking so long, but it is. Oh boy, gotta love Polybase. I am definitely doing something that wasn't necessarily, you know, I'm kind of taking this one outside of the box, but I feel like it should work, which is why I created this demo, and I wanted people, once again, I want you to be aware of it, because if you don't fix it, then obviously all of your external tables, I mean, think about it from a point of a DBA. So if you're, if this were to break, and then it would catch you unaware, and then all of your users, so it's like, okay, well, you think I'm great, I've got AlwaysOn, and so the database has failed over, but all of a sudden Polybase isn't working, which means it's not going to be able to connect to your external tables anymore, which means that all the reports that they've designed going against those external tables are not going to work anymore. So that's why it's important to be aware of this little finicky bit about it. Other than that, everything runs pretty darn smoothly. I mean, I think it's a fairly quick service. It's obviously incredibly advantageous to be able to have all your data available. And it is just taking as long as possible. It looks like it had some issues. So it is taking forever to start. Of course it is for the demo. That's fine. So the point is we're going to move forward. It is obviously unhappy, and I can try going to the scale out group and see what it thinks, but no, it's still stuck on that. So anyway, we're just going to move on. So let's go back, and we're going to just switch over. I'm going to pause it really quickly. Okay, so here we go. We switch back to our PowerPoint presentation. So node management's a little clumsy. Like I said, demo. Want you to be aware of. That's more of I want to give you empowerment of the tools. So let's talk a little bit about Polybase versus link server, because one of the first things that comes up to mind when you're talking about this, you think, well, isn't this just link servers? It's not. It's different. So Polybase is using ODBC versus OLDB. OLDB is a great connection, but it's much more limited, I think. ODBC is much more flexible. Other difference here is that Polybase in some ways is safer. Maybe you might feel more of an impediment, but right now you can only do read-only. So you can't actually insert onto the tables. So you can just read from them. But the truth is most of the reason why you pull data over from source systems is just to read it. You don't usually, you're not going to update that data. Why would you want to do that? I mean, you're doing massive ETLs in order to bring data over so that you can quickly and easily report on it. So Polybase is an extension of that. You're externalizing, you're visualizing that, virtualizing that data. Correct myself. You're virtualizing the data in the known data hub environment. Again, SQL Server 2019, that is your data hub, is that you have virtualized all your data so it's available. One of the nice things about this is that you're doing your security based on the database level as compared to the instance level, because link servers, frankly, are kind of a pain in the butt. I've worked with link servers for a long time. I mean, they're one of the oldest. They've been, I think, around since SQL Server 2000, and they've been before that, I think, even. But the point is that they don't work very well with AD accounts, I've found. So you usually have to do SQL accounts, which have their own unique problems. But also, it's also for the whole instance, because once you do it, all the databases are available. While Polybase, you can streamline that security and make it so it's only for that one database that you want it to. So link servers work just fine So as far as the, here I've got my point here and I'm stumbling across this a little bit right here. So we're just going to skip forward. But scaled out execution versus single threaded execution. Oh, I know. So the fact is that always on clustering out of the box versus configuring. So it does, even though Polybase isn't actually HA compatible, it still works just fine with it. It's only actually when you get into the scale out nodes. Because one of the things, if you noticed briefly when we were going through the servers, is that when you install Polybase, you have the Polybase databases on each server in the node. So you don't really, it's not always on, it's not HA compatible, but that's just because you have your own Polybase databases on each server. So if the server doesn't exist, it doesn't matter. There's not data that you need to share. Each one's keeping track of its own business, and then you use the scale out nodes to link them all together. Does that make sense to everyone? I mean, it's one of those things where I see it as if you do link servers, then you're going to have to come up with some fairly complex scripts in order to make sure that link servers work if you do an always-on sort of configuration. But finally, as I just alluded to, the scaled-out execution versus the single-threaded execution. I mean, Polybase was designed to take advantage of power wherever it can find it. So it's going to minimize the impact on your data hub server. It's going to push down as much as the work that needs to be done to the source servers. So the idea, and it's using TempDB. So the idea here is that you can add as many nodes as you want to. I'm sure there's a theoretical limit, but you can add as many nodes as you want to in order to scale out your performance. And also, it's a modern tool as compared to link servers, which are old. And so they're not taking advantage of all the modern bells and whistles that are in SQL Server 2019. I mean, that technology has just been brought along and made to work. So there's a lot of DMVs in Polybase, and we're not going to go through them. The documentation could be better, but obviously go to the Microsoft site. There are doc pages on each one of them. I think it's important to go through and understand them. And the key point right here is that the main error log is located in the diagnostics. So if you just go in there, like I said, the Polybase databases, all three of them are located on every installation of Polybase. So you're always going to have that errors one. And that's where you're going to find the information that you need to determine why the nodes aren't talking to each other. So one of the things I thought was kind of interesting I wanted to bring up, we're not going to do an active look at the DMVs, but I did want to show where you can see right here. So you can see here Polybase is going through and it's busy doing its work. It's in this case it was doing an insert into a local table. Like I said, you can't do an insert into the source data, but you can actually do it into the new one. So here, right here, and it's distributing the load. It's definitely multi-threaded. And then this one right here is a little bit more interesting because here you can actually see the node at work. So right here, if we look over here at this column, this compute node ID, so Polybase is going through and it's saying, okay, you go do this work, you go do this work, and you go do this work. This is where I'm pulling data where I had restored the Stack Overflow database onto one of my SQL servers in the cluster, and then I'm pulling them over to another one and creating a database from that. So that's, I mean, it's distributed computing. That's the whole thing. And right here, you can kind of see here also where, so in this case, it's not as exciting an example, but you have the head and then you have the data management service. But you can see right here, so TempDB is being brought into there. So Polybase is creating temporary tables in TempDB like it's supposed to, doing all that processing and then dropping the tables when it's done. It's cleaning up after itself. So again, it's taking advantage of the features that improve performance in SQL Server. A couple pieces of errata, just that it supports a few compression algorithms for flat files, and the main one that you're going to want to use is gzip, but zip is not going to work. So it's single threaded. So one of the things you might want to think about doing is that if you need to take advantage of, if you are going to use Polybase for serious work with flat files, you're going to want to go ahead and, ideally if it's a huge one, you might want to think about splitting it apart into multiple files in order to make it easier for Polybase, so then you can take advantage of the nodes. So the only insert at this point in time is on external tables. So you can insert on Hadoop and blob storage and such like that. You just can't do it on SQL Server yet. And you do have to use SQL accounts for external data sources. You can't use AD accounts yet. That's not supported yet. So I went ahead and created a SQL account in order to do that. As I already said, this slide I missed, but Apache is very important. I just updated my cluster last night to CU8, and it did fix a few nagging little issues, but you want to keep that up. And then finally, nvar car max is not supported in external tables. So why would you use Polybase? So maybe instead of keeping your historical data, so let's say you're a business that's been around for 30 years and you want to keep that the oldest 20 years of data around, you could store it in the cheapest form of Azure storage, but instead of having to go through the process, since you're storing in blob storage, you're saving a lot of money, but that data is still available. So as long as that blob storage is active, you could just go ahead and create external tables and you have them in place. And so in case someone needs to do that, so maybe you want to do some sort of a massive join or something like that where you want to do analysis of the EBITDA of the business for like the last 30 years. And so this would allow you to do it without having to actually bring the data and keep it present in maybe a much more useful system where the power could be used for something recent. Again, data warehouse, same sort of concept is where that, I mean, this is something I've actually been working with a customer as well too, where you can, you keep using the data warehouse, and so that you can just externalize the data. So you have your external tables against the data warehouse. That means you don't have to actually go into the data warehouse to get the data. The whole point is you're virtualizing your data. Lots of stuff here. I always put cat pictures into my presentations. So I hope you've enjoyed it, and during this session, I look forward to some of your questions. I'm not going to be able to answer all of them, but I'll definitely would be more than happy to work with you during this process. So we didn't look at any of the connectors. Sadly, that was my goal this summer, was to work on this, and I just got really busy. I'm very grateful to have a good job for a good company, and they keep me really busy. But I really wanted to set up, and I'm going to set up things like Oracle and even Ingress database. It should be fun. There's lots of speed and performance tests. I've gone through and worked with some of them. The DMVs are a little bit not very well documented, but they're still there. And then Synapse. So that's what I'm currently working with. It's a little bit different animal. There's a different form of Polybase. We didn't go into that. The main thing is it's exciting. I've used the phrase multiple times, give you back your power, but that's really what it's doing. It's the main tool to allow you to write in there, and once again, you're really in charge of the data, and you're helping the business be more effective because you can readily make all forms of data, old, new, different sources, easily available for the report people, the analysis people, to do what they need to do. But as you saw, it's a little bit clumsy, and there's some things that need to be worked out. Got a few resources here. Unfortunately, there's not a whole lot, but anyway, it's something to look for. So thank you very much. And please fill out the session evaluation. It makes all of us do a better job.